that last two slides. Oh, no. Can you hear me?
Yes, yes, we can. And we see the screen also.
Yeah. So these are the actual, if somebody is very keen to learn about mathematical morphology, and some of these lectures were given on a, almost I have spent 18 hours to give very basics of mathematical morphology, binary, grayscale, and graph morphology. And they can really understand from these links. And I would see a way to share this with Professor Hikri. And because in PDF file that I sent yesterday, I don't think those YouTube links are properly inserted. But this PPT slides I would share with him. And from this, you can attend these lectures and then understand. Of course, you can always contact me whenever you feel like having some doubts clarified. And so with that, just to give a quick recap, and not all that is available in mathematical morphology that I could explain here, but a few topics like granulometric analysis to study the roughness characteristics of terrestrial surfaces as reflected through digital elevation models. Here the very important data is digital elevation model, and very important technique is mathematical morphology. And then what is to be derived is the job of the domain expert, and we are all domain experts, and knowing this mathematics and applying that on very relevant digital elevation models would give us many more different directions, new directions to study the terrestrial surfaces. And these are some of the books that we published. It is on I always say that those 5 ingredients of spatial data sciences, retrieval, analysis, reasoning, modeling, and visualization to study the spatio-temporal behavior. And we have actually collected several papers along with John Serra, who is the founder of mathematical morphology. We edited this. And then advances in mathematical morphology were given here in filtering and segmentation with mathematical morphology. Here, a handbook of mathematical geosciences, chapter 35 is all about a kind of illustrative examples of mathematical morphology. And for Indian remote sensing and IEEE wanted to release a special issue. And then Earth observation and remote sensing in Indian territory. And this is what we released in 2017. And then this is the book that I have written in 2013, and where you have mathematical morphology, easier to understand mathematical morphology. But if you look at the morphology that is written by founders, and they are actually pure mathematicians, and sometimes to put that in perspective, and I would really recommend this book is easy to understand. If you are really keen into venturing into mathematical morphology, I would really recommend this. And then there is a call for papers. There is a call for papers here. This is oh, what happened? Screen sharing got somehow a problem. And then yeah, even this one I can just show you.
You can see the screen.
Yeah. So I'll just view full screen. And this is the call for papers and mathematical morphology in geoscience and remote sensing, which is open. The window is open for the submission now. If anybody is interested, can have a look at it. And so with this, probably I'll just close my talk. It's open for question and answer session. And let me acknowledge that I'm really grateful to the IEEE GRSS choosing me as a DL. through which I got this opportunity to share my work with Saudi Arabia GRSS chapter. And thanks to Professor Hikri for arranging and hosting this DL talk. So yes, and I'll stop sharing this, and please feel free to ask me any questions.
Okay, thank you, Professor Daya. So I first of all, I would apologize for the cut in the videos. Unfortunately,
No problem. That's all fine.
I'm right now not at the university, and so the version is not it's the basic version. All right,
Yeah.
and but we enjoyed it. Thank you very much. And now I open the floor for one quick question. The special issue is which journal? Geoscience
That is
Letters?
IEEE J-Stars. IEEE J-Stars.
J-Stars.
Journal of
J-Stars.
Selected Topics of Earth Observation and Remote Sensing.
Okay, great.
Yeah.
Okay, I open the floor for questions from the audience. If anybody has a question, you can go ahead and raise your hand. Okay, then I think I want to start.
Yeah.
Actually, I remember morphological operations. We used to use them some time back to do, we work on image classification, remote sensing image classification at the pixel level. So we used to use a lot of morphological operations to extract features and then use it and do classifier to classify the pixels. I didn't see it used in DEMs before, but this is nice to see it used in that area now. Actually, what happened is that since 2012, and since the appearance of convolutional neural networks, all work now in remote sensing is just using deep learning and convolutional neural networks, and we don't see any of this work at all anymore.
This is a common comment I used to get. Yes.
Yes. So my question actually is, I mean, convolutions. It's very clear that convolutions convolution operations are very powerful in terms of extracting features. And now with CNN, we can make them automatic to extract any features from images, other signals. Morphological operations used to be very strong in the past, and now it's kind of they're not using them much. But I mean, at the end, they both extract features, but they are different operations. I want to see your opinion about comparing convolutions versus morphological operations. And is it possible, one would think, can we use morphological, mix deep learning and morphological operations? I mean, is it possible maybe to do the same thing we did to convolutions, we can do morphological operations automatically using deep learning?
True. And so that was the question I used to always get from my students, because all younger generation people were looking at deep learning and convolutional neural networks, and why do we have to struggle so much to classify the images of this complexity? And with deep learning and CNN, and it would really help us. And but I didn't do any work on that. But of late, we started collaborating with the person who works in graph mathematical morphology is my collaborator, Professor Laurent Najman from University Paris East, and we are using a kind of layer in that CNN. That layer is a watershed layer. So since you are familiar with morphological operations and their applications in image classifications, watershed transformation is one very powerful transformation for segmenting the images. And by introducing the watershed layer, can we speed up the process of classifications? And that is what we have started a few months ago, and we are yet to see the results. But yes, it is. There were some studies, and we are seeing in some conference publications they are published, conference proceedings. The linking the morphology with deep learning. So many are familiar with deep learning, but morphology is, as you all know, that it is a field very popular in Europe, not in the rest of the world. And but I'm sure since you graduated from Canadian University, in Canada there are a few groups, a few pockets where they use mathematical morphology. But to your question, yes, And there are some links and which need to be established. The links between mathematical morphology and deep learning. I read there is some acronym, Deep MorphNet. Somebody has used this idea, Deep MorphNet, and I think with that, some leads may be there to really venture into mathematical morphology into the neural networks.
Yeah, so I think it's that's a very good idea. It looks like. I mean, imagine. I'm just imagining. I don't know how to do it really. I'm not that really good in mathematics also. So. But imagine
No,
if
yeah, morphology is
imagine.
not that difficult. Yeah.
Okay, imagine if we can remove the convolutional layers, and instead of convolutions, we use morphological operations, and then we create
Yes.
this what is called deep morphnet. So students who are
Deep
listening to this
MorphNet. Yes.
lecture, if they can,
Yeah.
if one of you can do this, this is another big improvement, big contribution into the area of
True.
machine
And
learning.
I'll get back to you once we have some concrete results on that.
Okay, yeah, sure. So
Yeah.
maybe someone
Yeah.
student maybe gets interested to do PhD in this direction,
Yes.
to
Yeah.
use
Yeah.
them,
Yeah. Yeah.
use
Yeah. That
these
would be
morph
great.
nets in classification of
That
scene,
would be
stuff
great.
like that.
Yes. Yeah. Yeah.
Okay, guys. Anybody else wants to ask a question? Okay, yeah, Professor, I want to also clarify some things that was not clear to me, maybe
Yeah.
also to other attendees and especially students. Like you mentioned, there is a slide where there is a lot of DEM satellites, or are these satellites that produce DEMs?
Yes. And all those DEMs were, the digital elevation model is a secondary product. And they take the images. From the images, they generate digital elevation models.
Okay, that's my question is, I mean, are they special sensors to do that, or just basically optical images and then they create?
No, actually optical image based digital elevation models are a bit erroneous if you are looking at for own ground elevations,
Yes, there
because
is.
the canopy and trees and all that would give a erroneous heights.
Yes,
But whereas microwave synthetic aperture radar based DEMs are more appropriate because they suppress these terrain features, and
okay.
it gives the true ground elevation heights.
Yes, good.
Yeah, they are actually byproducts from remotely sensed data. And this is what I was, the shuttle radar topographic mission SRTM team leader was one Dr. Paul Rosen from Jet Propulsion Laboratories. He visits us very often. And he used to tell that, yes, there are some uncertainties, but of late the DEMs, what we are getting are very, accurate, very close to the, very highly precise DEMs.
Oh, very good.
Yeah.
And the last application where you see you show the animation,
Yes.
the temporal between the start or the source
Source
elevation
and
and the
target.
target
Yes.
elevation.
Yeah.
It's a nice animation, but I wanted to ask about practical applications of this.
Yeah.
Is it just to view it and to have fun, or is it really it can be used for practical,
No. Actually,
economical reasons?
practical application is, let us say, we have a desert DEM,
Okay.
deserts, and those DEMs are, unlike on land, in a hilly region, they in deserts actually they get change their morphologies very often because of wind directions and the strong, endogenic forces that act on the thing. Desert region, because it's all loose sand. And if you have such kind of digital elevation models at multiple time periods, and we can actually study the dynamics of desert dunes, dune patterns and how they are changing with seasons and with times and across annual intervals. And from there, actually, we can extract a lot of many scientific outcomes.
To help us fight desertification, for example.
Yes, desertification, yes.
Yeah, okay.
And that is one. And on lunar digital elevation models, because it was less impacted by anthropogenic activity, and how those volcanoes were erupted, and then how those the crater rims were degraded, what is the level of degradation, and all that we can derive from the craters that we can derive from digital elevation models of lunar and Martian surfaces.
All right, excellent, thank you.
Excuse me, Dr. Daya.
Yeah.
That means there is an interest field here in our country, like empty quarter, because the desert there is moving. So we can use the DM to study the information over time.
True. And I don't know whether you have any facility to, through LiDAR-based digital elevation model that can be generated for, Saudi Arabian desert regions. If you have such a kind of facility, those DEMs generated at different time periods, and we can take those, temporal DEMs of a specific region as a prototype study, and we can use differential morphology. And so we can create, let us say there is a DEM of 3 months back and now, and within these 3 months, how this desert DEM has been transformed and how it is morphologically changed. And we don't have the data, but we can actually simulate the data in 3 months time, how this desert region has been morphologically changed. And such kind of things, yes, it is possible.
Yes,
it is possible. Yeah.
Yes, Doctor. And the other issue now we have in Saudi Arabia for transportation, like highways between east and west, or east and the middle of Saudi Arabia, the big highways, there is sand is moving. So we can study these issues.
Yeah. We can study if you have, for 6-7 years period, if you can study, and during which period, which time the sand would be drifted towards the highway, and those things, I think theoretically possible, but so once we see the practical data, and it would be very interesting.
So how can we collect the data? You mean?
You have DEM data for those reasons. I think SRTM 30-meter resolution data, you can just have a look at it at the beginning, and then slowly you can think about, LiDAR DEMs and drone-based DEMs you can generate. And if you have a facility, I think that is, the superficial dynamics, desert dynamics you can really study. And there is one University Nevada, they have a desert research institute. I'm sure they may be using DEMs. University Nevada, there is a DRI, Desert Research Institute. And you can just have a look at that DRI, whether they are using DEMs. And I'm sure that nobody is using mathematical morphology, but we can really try how morphology can really offer something useful in desert research.
Yeah, Doctor, and we can, I think, from these studies, we can propose the area that we can establish facilities for it's a good location or a bad location.
Yes. Yeah. That should be possible. Yes. That should be possible. Yes.
Yeah, good. Doctor. So good applications, good practical applications.
Yeah, there are applications. Yes.
Yes. All right. Thank you very much, Professor Daya. That's
you.
all I have time for today. I thank all the attending the audience for their time.
Yes.
Yes. I hope we have to meet in person in better times.
We'll see.
Inshallah.